So let's just go through, I want to go through a couple examples. It's been, almost 2 weeks. It's been a long time since we did this stuff. Didn't any hard problems. So let's go through some harder chain rule examples, right? Some derivatives that involve chain rule. These are the ones, remember, before break, we talked about, it's not, the calculus is, it's not, taking derivatives is really not that hard. It's simplifying, sometimes it gets hard, right? It's actually taking the derivative. You guys know the rules now, right? But it's the part after that gets a little tougher. So let's do this one. So we'll differentiate. Okay? So talk to me about this right away. Some things we might want to think about.
It's a product rule.
It's going to be a product rule. What about that 1/2? Do we want to? We have some options. We could group this as a product. We have a number of ways we could think about this. We could group it like that's one factor and that's one factor. What are the disadvantages of that?
No, we've got enough more numbers.
Say it again.
Got enough more numbers.
Okay,
That's
and
square root is chain rule.
it's going to be chain rule. But what about that 1/2? It's not a huge deal, but if I keep that 1/2 as part of the product rule, I'm going to have a lot of fractions showing up in my answer, right? And then we're going to have to, factor out the fractions. So why bother? What might we do with the 1/2 instead?
Just leave it off to the front rather than.
Yeah, just pull it out front of the derivative, leave it there, and we'll just distribute it at the end, right? We're all done. So instead, how about if we group it like this? There we go. So let's group it like, leave the 1/2 out front and just make that our product, right? So now when we differentiate, we've got our 1/2 and then just a bunch of stuff for the product rule. So what's our u? X to the 7th. Okay, so we've got a u. What's our v? Okay, the square root of hand, right? You get the square root part. So let's differentiate that. That's going to require some chain rule. What's the derivative of the square root of hand?
1/2 square root of hand times,
So,
2x.
okay, because that's a 1/2 power, right? Derivative of hand to the 1/2 is 1/2 hand to the minus 1/2, and you've probably all gotten used to this pattern. So there's my 1/2, and hand to the minus 1/2 just means the square root of hand on the bottom, right? So, but there's another layer to that, right? We have the square root of hand, but then inside that we got the derivative of 8 minus x squared, and what's that? So we're going to have another layer, minus 2x, plus, so what is that then? That's really just u times, times b prime, right, plus the u prime we need. What's that going to look like?
Square root of 8 minus x squared times 6.
Times right? Calc's done. That's it. Calculus is done. Now we just have to simplify that. So what are some ways we can do that? There's two perfectly equivalent ways of doing this, and neither one of us is right or wrong. Let's do it the way we did last time. The way we did this last time, before the break, we would have just dealt with this as a fractional exponent, right? So we would have actually rewritten that as the quantity 8 minus x squared to the 1/2. And so if we rewrite it that way, we got 1/2 times x squared. I could put the 2 right there with the x squared, but then I've got an 8 minus x squared to what power? negative 1/2. Do that, I guess.
Isn't it x to?
Oh, whoops, and I have that too, don't I? Right? Did I make a mistake?
Isn't it x to the 7?
Oh, you're right. Yeah, what am I doing? You're right. Plus, over here I'd have my 7x to the 6th times 8 minus x squared to the 1/2. Do you agree? And I could even clean that up more. Well, I could do this. That helps a little better, right? Let's just go one more step. Let's combine those. So I'm gonna get a minus x to the 8th, right? Times 8 minus x squared to the minus 1/2. Plus 7x to the 6th times 8 minus x squared to the positive 1/2. Now we can clean this up, right? So this amounts to simplifying by factoring out the least powers, right? So what are the like bases that I could factor out here? Okay, so I'm seeing, I've got the base 8 minus x squared, so there's one. Like base, what's the other one? Well, it's x to some power. I've got x's also. Okay, so let's factor those out then. So out front with the 1/2 now, we can just lump all those together. Got a 2 on the bottom. I can take out what power of x? X to the 6th. Okay, here's the one that's just a little trickier. What power of, and don't say it out loud, just let me just think about this for a second. What's the power of the other base, 8 minus x squared, that I could factor out or distribute? Second view. Remember, I always factor out the least power of each base, right? So what are the powers here? I've got negative 1/2 and 1/2, which is the least of the two. Negative 1/2. So we'll factor out an 8 minus x squared to the minus 1/2. And now what's left behind when we do that? So here I'm left with what? Negative x squared.
Wait, how did you get negative x to the 8?
How did I get that? Let's see. What did I do? Oh, I just, right. So we had a negative x there times an x to the 7th. Okay. Good. Okay, what about this base? What's left behind? There's 1, right? So that one's gone. It's gone from there. And we get plus, how much of that base is left? Just, right, the x's are gone, so I just get a 7. Okay. So this guy goes. Makes sense that when you see this pattern, right? This isn't an accident. You can kind of predict it's going to be this way every time. It just helps to see these little patterns. So you know that when I've got a product rule like that, one of the bases is going to disappear from one term and the other base always disappears from the other term, right? Unless there's been something that's, where we've done some other simplification that's kind of messed things up. But you see that pattern, right? And then what's left here from this guy? So I divided away 8 minus x squared to the negative 1/2 from 8 minus x squared to the positive 1/2, right? So think what that looks like. I've got some quantity, who even cares what it is, some quantity to the 1/2 divided by the same base to the negative 1/2. What's our rule of exponents say? Subtract, right? So I'm going to end up with whatever that quantity is to the 1/2 minus negative 1/2, which is to the 1 every time, right? Not an accident. It's always going to be that way because of the power rule. The power rule reduces the exponents by 1 So the powers are always gonna be separated by exactly 1, right? So we end up here with 8 minus x squared. And now all I would have to do is just simplify that a little bit, right? No big deal. Okay, so I could combine some stuff in here. If I distribute the 7 and add like terms, what am I gonna get inside the bracket? That's all gonna simplify down to what? 56 minus 7x squared minus another x squared. Okay. Could I factor something out of that? Yeah. So see that I could take an 8 out of that? So all this stuff would actually just become 8 times 7 minus x squared, and then all this still has to come down, right? So I've got my x squared times 8 minus x squared to the minus 1/2 over 2, so I could do a little simplification and make that a 4, right? If I do it again, oh my God, that's something against 6 again. And so what do we get then? 4x to the 6th. That's going to go to the bottom, right, because it's negative. So I get 4x to the 6th times 7 minus x squared, all divided by a negative 1/2 powers the square root on the bottom. There it is. Okay. Yes, sir.
Does it matter if you put 7 minus x squared, maybe x squared plus 7?
It doesn't matter. Doesn't matter. Really, I always like to, I don't know why. It's just, I always like to put the positive term first. No, it shouldn't make any difference. Shouldn't make any difference. I just think there's a smaller chance of making a mistake if you put the negative in the middle, personally, but it's no big deal. That's a good form though, right? Why is that such a good form for the derivative? It's factor, right? What are the zeros of the numerator? 0, right? By the zero product property, the top is 0 when x is 0 or x equals what? When would that factor be 0? No. If I said, when is 7 minus x squared equal to 0? When x squared equals 7, so x equals plus or minus the square root of 7, right? So I get 3 zeros of the numerator. What are the zeros of the denominator? It'd be weird. Well, not that weird, I guess. Plus or minus square root of 8, so 2 radical 2. Okay? So that tells us a lot. It tells us a whole lot about this derivative. It tells us the derivative is undefined when x equals plus or minus 2 radical 2. It tells us that we're going to get zeros of the first derivative. Now what happens? I want you to think about the behavior of a derivative. The job of the derivative function is to tell us the slope of the curve, right? So what's unique about the original function when the derivative has a 0 value? What's that tell you about the tangents to the curve there? Or the slope of the curve, in other words, if those horizontal. Horizontal, right? You get a horizontal tangent where the slope is equal to 0. So we know that we're going to get horizontal tangents when x is 0 or plus or minus radical 7. That's really important, as we'll see, in about a month or so. Okay. All right. That makes sense? Okay. How else? And I don't want to, belabor this too much, but there's a lot of good math here. How could we? What if we had just stuck with this? We don't have to go through maybe the whole thing, but I want to at least show you how you could have. Okay, do you see, and we don't have to go through the whole thing. I think the way we did it the first way is better. But I could also just write this as fractions and get a common denominator, right? So I could do this, get the very same answer. I could write this as 1/2 times, if that's a fraction, it's just x to the 7th over 2 times the square root of hand. The 2's cancel, right, and that becomes an 8, I guess, if I combine. If I multiply those out, we agree. There's the first term. Second term is just gonna be square root of hand times 7x to the 6th. But what do I have to do to get a common denominator here? Good, square root of hand over square root of hand, right? So if I were to do that right here, then I get my common denominator, right? So I've got common denominator of square root of hand. And on the top, I've got a negative x squared plus, what? How many times am I gonna do that?
That's 3.
I wonder what I've got in my head that keeps causing me to do that. I don't know what's going on. So over here then, on the top, I've got 7x squared times, what's the square root of hand times the square root of hand? Hand, now it is supposed to be squared, isn't it? Oh my gosh, are you kidding me?
Because you're 52.
Exactly, that's it. That's it. Times square root of hand times square root of hand is just the hand, right? So do you see, if I just combine like terms there, and that's actually already factored a little bit, isn't it? If I combine like terms and I, distribute here and I factor out an x to the 6th, it wouldn't take very much effort to get that to look like that, would it? Right? I mean, I don't know if it's harder. I just think it's, this is more consistent because you're gonna do it for the quotient rule too. If for what it's worth, I'm not saying there's a big difference here. I would do it this way. I would always do this problem, I would do this way with powers and factor out these powers, personally, if that's worth it. But I can't really articulate. I haven't really thought that hard about why I do it that way. I just would though. What's that?
First one?
I would do it the first way. I would do it this way, where we're writing it with negative exponents and factoring out the least powers. Okay. Okay, what about something like that? Okay, what are our options, first of all? I could use quotient rule there. What else could I do? I could use quotient rule. You will be.
Rewrite.
Say it again.
Make exponent negative and put it on top.
Yeah, exactly, and it'd look almost like the same problem, wouldn't it? If I did this instead, if I wrote this as x cubed times the quantity x to the 7th minus 14 to the minus 1/2, that's just about the same problem we just did, isn't it? Right? It's not gonna be any harder, really, right? Only difference is we're probably gonna get some fractions in there we gotta factor out. That's it. I'll leave it to you. Do you wanna go through this one? Okay, seeing some head nods. I think that's good. This is a process. I mean, it takes a little practice. So let's go through this. And we could do it either way, but let's do it this way, right? Product rule is easier than quotient rule. Not only is it easier to execute, it's more foolproof because there's a plus sign between the two terms, so you can mix them up, right? All right, so here's our U. Here's our V. So by the product rule, what are we going to get? Not everybody all at once, that'd be bad. I wouldn't understand. So x cubed, get u times, thank you. U times v prime, what's v prime gonna look like? Emily, what's v prime gonna look like? This is a chain rule one, there's v. So what's v prime gonna look like? Derivative of hand to the minus 1/2. What's that power rule say? Hand to the minus 1/2. How's that gonna work? So derivative of hand to the minus 1/2. Minus 1/2 times hand to what power? Right, we're just subtracting one. Right? That's our rule. Okay, and hand is just x to the 7 minus 14, but there's two layers there, right? Two layers to the function, so I need two links in the chain rule. What's the next layer gonna be? 7x squared, 7x to the 6th, plus, that's nice, right? 7x plus, v u prime, right? So, what's u prime?
No, 3x squared.
3x squared. Okay, there it is. So this is maybe a little bit tougher just because we've got a fraction there. So let's figure out what are the things we're going to factor out. We want to definitely take all the fractions out, right? So we want to, there's only one fraction here, so we want to divide each of the two terms, and there's left term, right term, right? There's our plus sign, we got two terms is all. We want to divide each term by 1/2, okay, to get rid of that. So we've got our, should we just make it a, no, yeah, 1/2. So that goes away. What about the bases? What are my like bases? I've got what's and what's here. Got x's. We didn't really combine those, but we can do that in our head. Okay, good. And we've got these guys. We've got the blue color here. We got those, right? Okay, so we can take out how many x's? I've got a total of x to the 9th. Over here, I've only got x. So I can only take out x squared. What about this guy? That's supposed to be a minus 1/2, isn't it? What power of the other base, the big base, can I take out? Negative 3/2, the lesser of the two, right? And then what are we going to be left with? Okay, so what about dividing by the 1/2? If I divide 1/2 by 1/2, it goes away, right? So the 1/2 is gone. I'm left with a negative, though. And negative, what if I've got 7? Right, there's a 7. I've got x to the 9th divided by x squared, x to the 7th. Okay? This guy goes away completely, right? We divided that whole thing out front, factored it out. Very good? Okay. Plus, what about over here? So I've got a 3 is my constant. I'm dividing by 1/2. Dividing by a fraction is equivalent to what? Multiplying by the reciprocal. So what number is going to be left with my second term? 6, right? If I'm dividing away a 1/2, I'm the same as multiplying. Factoring is division, isn't it? If I factor something out, I'm dividing that away from each of the terms, right? Pulling it out front. So I'm left here with the 6. We can easily demonstrate that to ourselves. If I were to distribute 1/2 times 6, gives me my 3, right? The x squareds are gone. And then what power of the big base do I have? Guaranteed? 1, yeah. So then I get, okay, that looks pretty good. All right, all I gotta do is just combine these terms. These are easy to combine. All the fractional powers and the fractions are out front, right? So it's easy cleanup here. What do we end up with? If we divide this up into a top and a bottom, I've got, let's see, on the top, well, what's all this stuff gonna become, I guess, first? So if I distribute negative 7x to the 6th plus negative 7x to the 7th plus 6x to the 7th is what? Minus 84. That's that whole thing, right? Okay. Let's pull the minus sign out front, how about? And make that a negative x squared times this. Everybody agree? Okay. And then on the bottom, we've got a 2. I've got a 2, and that's negative, so I've got a hand to the 3/2. Right? That's great. Okay, what are the zeros of the numerator? What are the zeros of that factor? 0. Okay, so we're going to get horizontal tangents at x equals 0. Now what about this one? Those are going to be weird. 7th root of negative 84, which is just some number, right? Who knows? Some number. Those are going to be the places where we get horizontal tangents, and the derivative's going to be undefined at, what, the 7th root of 14? Okay, make sense? Okay. So what about that? Just more chain rule practice. So at the outermost level, what is that? Square root, yeah, square root, right? Yeah, square root of something. Now inside the square root, when we dig inside that first layer, we got a quotient. But the outermost level is just a square root. So if we calculate y prime here, what's the derivative of square root n? 1/2 square root, square root on the bottom, right? Hand to the negative 1/2, so. Right, so there's the first layer of the chain rule.
And it's okay if we split it like that?
No, we'll simplify it. We'll simplify it, yeah. Times, now we got inside, we got a quotient rule problem, right? So quotient rule, what are we gonna get? There's my u and there's my v, right? So what's the quotient rule? So, right, so low D high minus high D low, so I'm going to end up with a v, which is an x plus 1 times the derivative of the top. U prime, what's that? You know what? Minus, good. You got to get a minus. That's important. Minus top times derivative of the bottom, which is 1. So we don't have to write it. Divided by bottom squared, right? Okay, so what's it mean to have 1 over? How can I simplify that part? What is the reciprocal of the square root of 2x over x plus 1? Yeah, but what's that mean? Like if I've got, let's just focus on that part. What if I've got 1 over the square root of x over y? What's that work out to be? If I have the square root of a quotient, I could just split that up. You don't have to do all these steps, but I want you to see how it works. I could break that up into 1 over the square root of x over the square root of y, right? Well, that's just a regular old reciprocal, right? I mean, regular old fraction. If I divide by a fraction, I'm multiplying by the reciprocal. So wouldn't that just become the square root of y over the square root of x, which simplifies to what? I mean, if I want to, the square root of y over x. Everybody see that? Okay. We don't even probably want to do that last step. Would you agree, though, that this first term then, I could just write this as, if I wanted to, I could just write this as 1, not 1, the square root of x plus 1 on the top, and 2 times the square root of 2x on the bottom? Right? Times, what if I simplify all this? I'm going to get 2x plus 2 minus 2x. What's that? 2 over x plus 1 to the 7th.
Squared.
Squared. Exactly. Yeah. I would have been so mad if I didn't. Finally got it right. So the 2's cancel.
It is squared.
Is it really? Oh my God, I thought that was, I wasn't joking. I can't read my own writing. I thought that was 7. I got ya. Holy smokes. Okay, so then look what happens. The 2's cancel. Now, what about this? I've got an x plus 1, same thing as x plus 1 to the 1/2 on the top. I've got an x plus 1 to the 2 on the bottom. Look at that. So what's that look like then? Right, the 2's are gone. I'm stuck with a square root of 2x on the bottom. What is that? Just by the, properties of exponents. If I have a to the m over a to the n, what's that equal to? A to the m minus n, or you might remember back in Algebra 2, if n is bigger, we can just jump right to 1 over a to the n minus m, right? And so that's just going to be on the bottom, x plus 1 to the 3/2, right? 2 minus 1/2, 3/2. Make sense? That's kind of an awkward way to write it, but that's our answer. That's actually how we want to have it written, though, because once again, we want to have this written in the form where we can look at this and say, what are the unique zeros at the top? None. What are the zeros at the bottom? 0 and -1, right? Okay. And we haven't gotten there yet, but you can kind of see that's obviously where we're going. Okay? Questions? Okay, so last little bit here. We're not going to get very far, but I just want to, this is just another chain rule thing, right? So if we want to find dy dx, this is like the clock example that we did, about 3 weeks ago, or whatever it was. It's been a while, right? So if y equals u squared and u equals sine x, and I want to calculate dy dx, how could I use the chain rule here? Dy dx equals, okay, which is just dy du times du dx. And you know this works because algebraically the du's cancel, right? Okay, so that gives us, if I actually plug in the values there, dy du is just 2u times du dx is what? Cosine x. We could write u in terms of sine x, and what does that become? 2, what's u? Sine x. 2 sine x cosine x, right? Okay, no biggie. What about this one? This is different. This doesn't even show up in the textbook, but I want to show this to you. This is kind of a physics thing a little bit. This is called a parametric system. right? So we've defined x's and y's in terms of a third parameter, t, okay, another variable, t. So x's are written in terms of t's and y's are written in terms of t's. There's a really simple way to formulate the chain rule. And look what the question is actually asking us here. It wants us to write the equation of the line tangent to this curve, right? And this could be a real object. Think of it as a particle moving in the xy plane. This is describing the horizontal motion of the particle, and this is describing the vertical motion. And right before class, I just kind of threw something together here I'm very proud of. Let's take a quick look here. Oh, where'd it go? Did I actually lose that thing? Oh my goodness. I lost it. If you drag it off the screen, it goes away? How can that be? That's terrible. Let's see if I can pull this thing up again.
You're so excited.
I was really excited. Oh, there it is. Got it back.
Yay.
All right. Oh, so happy. Okay. Okay, so check this out. What I've done here is I've graphed, here's a particle. We want to isolate the x component of this particle's motion and the y component. So all I've done here is I've just graphed the point t over pi plus 3, because that's the x coordinate, right? So if I turn that on and I just animate this, where I'm going to let the value of t run from -6 to +6, look what that does. So that's the x component of this particle's motion. Think of it this way. That's the component of the particle's motion you would isolate if I were looking down on the particle as it's moving in the xy plane. Right? If I were looking straight down on it, I would only see its horizontal motion. I couldn't really resolve its vertical motion, right? So let's look at the other part. The point 0 sine t. Okay, so now there's the y component. Right? So if I were looking from the side at this particle, so I couldn't resolve its horizontal motion, that's all I would see. So what happens if I superimpose those two? That's the actual path of the particle, right? So what we're asking here is we want to know right at t equals pi, which is right about there. Oh, I went a little too far. But at that point right there, we want to know what is the equation of the tangent line, right? So the particle is moving. Everybody get a sense of that? So the particle is kind of moving. I wonder if I can actually leave a little trail behind it that. But wasn't it kind of doing this? It was kind of going, yeah, it was kind of making a sine curve. It was kind of coming down this way, sort of going down like that. So we want to know what's the equation of that tangent line, right? Okay. So how could we be tricky about this and use the chain rule to do that? Because we can do this really simply. It's such a cool problem, right? We're trying to come up with dy dx, right? Well, are we out of here like in 1 minute?
Yeah.
Okay, we'll just leave this off. Think about that a little bit. Tomorrow we'll pick that up.